So let's start building up our toolkit of theorems that help us with basic things to do with measurable functions. Here's my first one. It's going to be that the composition of measurable functions is a measurable function. So to compose measurable functions, I'm going to need possibly 3 measurable spaces. So let's say x1, x2, x3 with sigma algebras a1, a2, a3 respectively. And let's assume I have a function f from x1 to x2, except sometimes I like to write it like this instead. x1 to x2, like this. So assume we have a function like this. And this, for some reason, this helps me think about composition more fluidly. So let's say G maps x2 to x3. And let's assume they are both measurable. So measurable functions, meaning f is a1, a2 measurable, and g is a2, a3 measurable. Then I claim that g composed with f, which will be this kind of map, is measurable. And by that I mean a1, a3 measurable. Proof. So assume the hypotheses and let, let's call it A, be any measurable subset of x3. So let's say it's in the sigma algebra A3. Then I need to think about the preimage of A under G composed with F, right? But that's actually just first take the preimage using G, right? And then take the preimage using F. That's all. And since G is a measurable function, this portion here, the preimage under G of A, is going to be in A2. It's going to be measurable subset of x2, the middle space. And then since f is a measurable function, the preimage of that would then be in a1. So that's it. All right, so a composition of measurable functions is a measurable function. Sounds simple, the proof is simple, but it's going to be really powerful, as you will see.